Good to go. All right. So I'm really pleased to introduce Bhuwan Dhingra to you, who's from Duke. He works on knowledge-intensive tasks with large language models, trying to improve their trustworthiness and efficiency. Just a quick history. He graduated from IIT Kanpur and then did his PhD at Carnegie Mellon with William Cohen and also Russ Salakutnev. And he worked on the DeepMind team doing post-training for Gemini. And he now actually is also still has some time in the industry, I'm not sure how much, as a research scientist at Apple. But he is mostly at Duke. And I guess that's where this work is coming from. So let's welcome him.
Thanks a lot, Jason, for the introduction. Yeah, so thanks a lot for having me here, and thanks a lot for attending the talk today. Yeah, I'm going to go over some of the recent work which has come out of our group at Duke. I run the Duke NLP lab. Yeah, let's get right in. Yeah, so I think it's not at all controversial to say in 2026 that chatbots are becoming a primary source of knowledge, right? So today, if you have a query, something like, is coffee good for you? You're very likely to open your favorite language model app and enter it there. And the response that you will get is going to be quite fluent, mostly coherent, and actually also mostly correct, right? So in this case, you might get something like, yes, moderate coffee consumption, about 2 to 4 cups per day is generally good for your health. It's linked to a lower risk of heart disease, type 2 diabetes, and so on. It improves focus, mood, and physical performance. For most adults, the benefits outweigh the risks, right? However, people who are pregnant, sensitive to caffeine, or have high blood pressure should limit their intake. Overall, coffee is a healthy addition to a balanced diet. Now, this is fantastic, right? So, so much information here, which I'm getting quite, accurately summarized. I guess I should say no to this, right?
Yep.
Just a few years ago, if I had the same query, I would have probably Googled it, right? And in that case, the interface that I would have gotten back was quite different. I would have gotten a bunch of links, some of them to authoritative sources, in this case, actually Johns Hopkins, or I might have gotten a link to Reddit where I would have gone in and read a lot of anecdotes that people are reporting, or I might have picked some research papers and try to read some of the research behind this question. So question, right? Which interface do you prefer? Which one do you like more, the search one or the chatbot one? So how many people like search?
I'm still old-fashioned.
Yeah. How many people like chatbots? Few. Yeah, I think that's actually quite representative nationally as well. So what you will find is that for search intents, a lot of people who obviously use search engines until a while ago, gradually, they're shifting more and more towards chatbots, right? And there's good reasons for that, right? So notice the amount of cognitive work that we have to do when we try to consume information from here. We have to click links, we have to go and read, and there might be a lot of caveats, a lot of conflicts that we have to manually sort of resolve in your head. On the left, the language model is doing the hard work for you, right? It's synthesizing lots of different sources and giving you one comprehensive summary, and people want that. But today, I want to sort of focus on what really is missing from this chatbot interface, and which maybe is part of the reason why so many of you still prefer the search interface. So one thing that obviously we don't get when we use language models is we lose problems, right? So in this case, yes, the model is producing information, and nowadays, that the error rates from these models are going down to hallucinating less. We're actually more prone to trust them blindly, right, and not question what exactly they're producing. Previously, when I was using search, if I click a link, I know I have some idea who would have written what I'm reading, right? Whether it's an expert or whether it's a random internet user. Now, not so much, right? I don't know where the model is picking up any of this. Another issue is about certainty, right? So notice the response has a lot of hedging phrases, right? Things like generally good, linked to a lower risk, most adults, should limit. And again, if you study, if you look at the kind of responses that language models give these days, they're really quite good at hedging. And there's a good reason for that. If you take any of the claims being made here, and you actually go back and look at the data behind it, I'm sure for a lot of them, you'll find sort of conflicting evidence, right? So for all of these, there might be some research studies which point otherwise that coffee is maybe not so good for you. So to sort of, hedge against that, you have these phrases here, but does that really tell me much about the certainty behind any of this? I don't think so, right? So maybe, it does give a signal that there is uncertainty, but how much, that's hard to say. And again, I sort of want to point back to the search interface where, if you're reading many different things, you come across conflicting information naturally, right? So on Reddit, maybe somebody would tell you that drinking coffee is bad for this reason. Now, that the language model is doing the synthesis. I think it's harder for us to come up with some sort of a confidence estimate. Yeah.
Just in fairness, before search engines, you might ask your doctor, and your doctor wouldn't necessarily give you an answer that was so different from this. They're also synthesizing, and they're trying to distill it to be easy for you.
But the doctor has a lot more context about it, right? Which the chatbot necessarily does not.
Context about me, yeah, maybe.
And
the chatbot may eventually know more about us than our doctors do.
That's possible, but I mean, in today's world, chatbots do make mistakes, right?
And so do doctors. I'm just saying it's quantitative. Yeah. Like I think search engines are a little weird. Like the fact that you see the conflicting information is an amazing thing about search engines, but it's not like something that's been around for most of human history.
I agree with that, but I think the point that I want to make is that as more of the cognitive effort is shifted to an automated system, we lose some of the richness in the interface. And lastly, I think most importantly, the question is, can I trust it, right? So at the end of the day, when I'm consuming information, or if I'm using AI for my work, I need to know, in what cases can I actually trust it, in what cases should I go and double check things. Now, ChatGPT will happily tell you that as an AI language model, it can make mistakes, but when real mistakes do happen, who bears responsibility, right? So as academics, papers are getting rejected in conferences because of fake citations. Lawyers are getting sued in court because they made up certain cases, and so on. And also, I think another sort of issue with trust here is that the whole process behind building the language model itself is quite black box, right? So we don't know what kind of training OpenAI does or Anthropic does on their models. What sorts of training objectives are they optimizing, right? So who's to say that Starbucks did not pay the creators of this particular language model to only say good things about coffee? So I think there's a broader issue of just the black box nature of the kind of process involved in building these models. Yeah.
So I have kind of a philosophical question about what you're trying to do here, because like if I think of when I'm doing Google searches for information, I'm not necessarily looking for the information so much as trying to find like a trusted source to then like read. And so like I guess I'm not even entirely sure like what the point of like a ChatGPT is supposed to be doing here. Like, is it supposed to be doing a similar thing of saying we want to find the most relevant information and feed it to you, or do you want it to actually like kind of synthesize all of the opinions? Because I think there is value in seeing like maybe the common opinion is wrong, and so even though I'm looking for the expert, like maybe I care to see what people think as well, and so it's like I'm not entirely sure like what exactly do you want the model to do in these cases? Are you trying to have better synthesis of the overall like search results, or are you trying to like actually extract the correct information?
No, so I think models are generally getting good at synthesis, right? I think if a few years ago you had asked the same question, you maybe would have only got the first paragraph without the caveats, right? So I think as time is going on, the companies who are building these models are getting really good at giving you more comprehensive, more longer answers which synthesize information from a lot of places. But the point that I'm trying to make here is that this output that you get is still quite opaque. You don't really get to peek into where this information comes from, how it was combined together to synthesize this particular response, or what exactly is the objective that is being optimized here. So ideally, I think that is the move towards more detail is actually nice. I think that's there's obviously some concerns whether people really want that, right? So for most users, maybe when they ask this question, they just want a yes or no. But overall, I think as an interface, we should be looking to expose more signals and more of the process behind how information is being synthesized. And that's really the point that I'm making.
Yeah, so it's a follow-up question, which you just said, like, is the raw search result not the most signals possible? So like, where do you draw the line in terms of like, what does a user want? Like, some people are going to say, give me the first sentence of the answer, and I don't know else. Versus some people do want to say, what are all of the opinions and how trustworthy are all of the sources and so on and so forth.
Yeah, I mean, so the users are going to do what they're going to do, right? So a lot of people are just going to read the first sentence and not even go through the rest of it. But the point is that does that mean that we sort of hide all of the information if somebody wants to access it? I don't think we necessarily want to do that, right? Changing user behavior is definitely hard, but I think as an interface, there's a lot of things lacking here which we can add. So I mean, some of those things Search had. Search is not perfect. But it did expose a lot of provenance, a lot of attribution, which is seen here.
Yes, if I can maybe rephrase what I think you said to make sure that I'm understanding. So basically what you want is that like users should get the information that they seeking, but if they want to dig deeper, they should be empowered to do that. And with this type of result, you lose the ability to
Exactly.
gain that. Okay.
Now, actually changing user behavior is a very important and interesting problem, which I don't know how to answer. But in terms of extracting signals from the model, I think we can still do quite a lot of things.
Yeah, that makes sense.
So let me move on. I think one question that I'd like to address right at the beginning is when I talk about exposing some of the model reasoning or providing more signals, one thing that you might be thinking of, okay, is this talk about interpretability? The answer is no, right? So I think interpretability, especially the kind of mechanistic interpretability which is dominating the field right now, that is really concerned about exposing model internals, right? Like figuring out what parts of a transformer actually lead to certain predictions, how we can control different or steer different activations within your transformer to get desired outputs. I think that's pretty interesting and that's very important. But personally, I am more interested in exposing signals which are useful to the end user, right? So somebody who's actually using ChatGPT to do their work or to search, they're less interested in the transformer mechanisms which underlie the outputs they're shown, but rather they're more interested in verifiability, right? So figuring out what sorts of things can I get so that I know when I'm likely to get a correct answer versus when I should go and maybe do some more research. So with that sort of background in mind, I'm going to go over 3 different works from our group on exposing different kinds of signals in this process of information consumption. In part 1, I'm going to talk about provenance, right? So how do we attribute any fact which is generated to the training data which might support it? In part 2, I'm going to talk about process. So, models are really great at reasoning, but can we get a peek into what sorts of reasoning process they're using? And sort of the answer there is going to be to look at tool calls. And then in part 3, I'm going to talk about uncertainty, especially how do we extract some sort of a confidence estimate when the model is producing very long generations. So let's start with part 1. This is going to be on a paper coming up at ICLR in a couple of months. Now, again, the question that we're interested in here is where does the model acquire its knowledge? And generally, I think with language models, there's sort of 2 sources of knowledge. One is what we call non-parametric knowledge. So this is stuff which is stored in external corpora. And given some prompt or query, the model first runs a retrieval over the external corpora or invokes a web search tool. It gets a bunch of documents and then conditioned on those documents, it generates a response. This is, this retrieval step and putting documents into the context step, this is sometimes expensive. So only about, studies have shown that only about 30% of ChatGPT queries actually use web search. But the good thing here is that because the documents from which the information is being extracted are right there in the context, you can actually post-train the model to cite those documents, right? So whatever outputs it's generating, it can also generate a pointer which goes back into the context window. The other source of knowledge is parametric knowledge, right? And this is stuff which is stored inside the model weights, right? So during the pre-training phase for the language model, it sees a bunch of documents and based on the language modeling objective, it memorizes a lot of paths. Now, in this case, when we use parametric knowledge, the setup is much simpler, right? So you're given a prompt and directly conditioned on the prompt based on the knowledge that the model already has, it generates a response, right? And due to its simplicity, this is sort of the dominant mode in which I think language models are still used today. So now the question here, of course, is can we actually train the model to generate citations to its parametric knowledge, right? So can we, in this case, the parametric knowledge is coming from the pre-training documents, so it needs to generate citations to one of those pre-training documents. Now here, I would like to contrast what we were trying to do with some related work on influence functions or training data attribution in general. So the idea behind influence functions is that you let the model make the prediction as it does without making any changes. But once you get the prediction, you go and you try to figure out which training data points maximally influence that prediction. And it's a post hoc process, right? So you don't intervene during training, but after you make a prediction, you try to re-rank all of your training data. This turns out to be quite expensive. So instead, what we're trying to do here is, can we actually go in and can we intervene on the training process itself, so that for every fact that is stored in the model's weights, there's also an associated sort of document ID or some sort of a citation. And then can we train it during post-training when it generates some responses to a prompt? Can we train it to actually produce those same document IDs or sources? So that's the setup that we're interested in. And we can start with some simple ideas. So one simple idea is to check whether models are already capable of doing this. So we can take what was at the time a state-of-the-art language model, GPT 4.1, and we can just prompt it that for whatever response you give, also give some citations along with that. This doesn't quite work. Models are quite prone to hallucinating citations without intervening on their training process. Then next, we can try post-training models, right? And now all of the results that I want to talk about are on a much smaller open source model, 22.57b. One simple idea is don't do anything in pre-training. Just take a bunch of question answering data sets, and in the responses, in the ground truth responses for those data sets, go in and add a citation at the end to teach the model to generate citations.
That's got to be a citation into the training data, the pre-training data?
Yeah. In this case, we were using sources like Wikipedia and Common Crawl, so we were reasonably confident that these are there in the pre-training corpus. And here, so the kind of citations that we were constructing were actually somewhat natural languagey. So we took all the documents in a curated pre-training corpus, and we made sure that the titles are all unique. So we added some sort of, we deduplicated all the titles to make sure every document has a unique one. And then you just train the model during post-training to generate those citations. This also doesn't work, right? And it's not surprising, right? Because it does memorize things on its training set, but now at test time, it gets a new question that it has, it doesn't know where that fact comes from, so it's not able to generate that. So this is where some prior work comes in. So one, we need to intervene during pre-training, and one sort of straightforward idea is what I'm going to call as passive indexing. So the idea here is that during the pre-training phase itself, let's go in and for every document that we're training the model on, let's add these citations in there, right? And there's a few variants that you can construct. You can add the citation right at the end, or at the beginning, or after every sentence. Then once you've done pre-training the model, hopefully it's going to memorize those document IDs. And now you can again do post-training, right? So that it learns to generate those IDs within a question answering context. This also actually ended up not working quite as well. So this paper from UIUC, they had a synthetic setup where they showed that this sort of idea can work. But when we actually do it on realistic corpora like Common Crawl and Wikipedia, we find that it actually doesn't quite work.
Bhuwan, can I interrupt you for a second?
Yeah,
just on that. So in the case where you had the the supervised fine-tuning, I can understand what you mean by, the question is, what's the y-axis? What is success? And there, since you inserted the particular citation, it's very clear. If you get that back, that's a true positive. If you get something else back, that's a false positive. Or if you don't get back what you put in, that's a false true negative and all that, right? In the more general setting, in the passive indexing setting, is there an automatic way, or do you have to do a manual inspection and say this?
Ideally, you do a manual inspection, but here we are using an entailment system. Right? When it generates a citation, can we actually check whether the underlying document entails the fact that it's supposed to support? So that's the metric that we are plotting on the y-axis.
Okay.
There is an automated check.
It's an automated, okay.
But ideally, you would have humans looking at that.
Okay.
But I think, from what we observed, the entailment system we were using was quite good.
Okay. And then what do you do if it's a spurious citation, if it doesn't exist?
So that would be counted as input. Right?
Automatically.
Yeah.
Even if it were off.
I would like to note that for all of the methods that we were working with, we did constrained decoding. So we did make sure that the generated citation did actually point to some training point. But in general, if you're not doing constrained decoding, then you would just count that as incorrect if it's a made-up citation.
Right.
Yeah, so isn't that sort of backwards from how people do this? I mean, it's actually a common failure mode where you read something and you see the citation. This is how people do like citation laundering, right? You have a flimsy idea, you write a blog post, and then everybody starts citing it, and nobody reads the original sources. And it seems like what you want to do actually is have it produce summaries of the original sources, and then it. Maybe I'm misunderstanding what you're doing here, but you're teaching it to learn what the citation was, when what you want it to do is actually know the content of the cited document.
That's what Google's AI companion does. I think it does a search, and then it summarizes the search results for you at the top with links to the documents.
Okay.
Yeah, so you
So
can
that's a RAG system.
post hoc citations as well, that you let the model generate and then post hoc go and look for things to support that. Here the idea is that can we actually store that process in the model itself, right? Can we, for every fact that it stores, can we also store a citation and then train it to generate those as it's generating the facts?
Okay. See, where are you getting the citation links? So you're getting it to learn the
This is
citation.
generated. So that whole string, which I'm calling a citation, this is actually generated token by token.
Oh, so you do generate from this primary source, and then you try to get it to memorize the citation.
Yeah. I mean, no, so the memorization happens during pre-train.
Okay.
I think the question is, how to revise the pre-training data to insert citations?
Well, you can go in and just manually insert them wherever you want, right? So there's a few different ways. You can add it towards the end, after every sentence, at the beginning.
And you say manually, like on 500 billion
I
points?
mean, programmatically.
Yeah.
Yeah.
But so when you insert these, are you reading the right hand document?
During pre-train, but not during intra.
Yeah, I'm talking.
So this is a
is a
case where
fine-tuning
there's a parametric component, right? So at test time, you're just given the question and you generate the response with citation.
Okay.
Yep.
Okay.
Let's
maybe carry that
Okay, yeah.
offline. But yeah, we did analyze why passive indexing fails, and it's really the problem is that it's really good at memorization, but not really generalizing to varied contexts. So here on the leftmost is when we take the passive index plus post-trained model, and we give it the same document that it saw during pre-training, and we would see that the citation accuracies were pretty high. But as soon as you move away from it, if you just give it a snippet out of that document rather than the full one, that really drops. Or if you give it a generated question and answer pair from that, it drops further. So it was quite clear that during pre-training, rather than just showing a document with citations, you need to do something more. You need to teach the model how to use those citations in varied contexts. And sort of the solution that we came up with here was to generate synthetic data, which increases the association between sources and facts. So given the pre-training corpus, and again, so I'm talking about pre-training corpus, but actually what we did was continued pre-training. We took a pre-trained model and on a smaller curated corpus, we continued pre-training it. But given that such a corpus, we can use existing LLMs to generate two kinds of synthetic data. One is what we call forward indexing. So the idea here is that we generate documents which pose a question and then produce an answer with respect to a certain source. So here, conditioned on the source citation, the model is learning to generate an answer which is true with respect to that source. And then the other kind of data that we generate is backward indexing. And here what we do is we take multiple pre-training documents and we combine them into one synthesized sort of paragraph or another document. And here the direction is reversed. So you first have the fact and then you have the citation, and you have facts going to fact from multiple documents along with their corresponding citations. So this is what we call backward indexing. That condition on a fact, the model should learn to generate a source. So we generate a bunch of data like this. We add it back to the pre-training data that we already have, and we then do continued pre-training. And this generally works, a bit better. So here, when you just do forward active indexing, which is conditioned on the source, you generate facts. You sort of jump from 10 to 20%. If you do backward active indexing, where you're generating sources conditioned on fact, that does quite a bit better, because here the model sort of learns to synthesize multiple documents and generate citations to diverse documents during pre-training. And then if you combine both of them, you end up get a slight benefit out of that as well. Now the actual number here seems quite low, right? 30%. That still seems quite bad. But the good news is that we studied some of the scaling behaviors of these citation accuracies. So first of all, model size matters a lot. So these are results with the 7B size model. If you use a 3B size model, then the accuracies are lower. So, that kind of makes sense that model capacity is a big component of whether it can memorize all of these, new document IDs that we're asking it to memorize. The other sort of direction where scaling seems to help a lot is the amount of synthetic data that you generate. So in our experiments, we only were able to generate till a certain amount of synthetic data, but we didn't see any sort of saturation. The more synthetic data that you can generate, the better it seems to do. So what I think is if we have, we don't have the resources to actually do those experiments, but companies who are building these models, they're dealing with much larger model sizes, and actually synthetic data generation is a very, very big part of the process of constructing pre-training data. I think that if you scale this up further, we can teach models to do a lot better at this job of generating citations.
So quoting a question from Zoom online, Kaiser Sun asks, could the added data be in conflict with existing pre-training data corpus?
Generally, you would have conflicts all across your pre-training corpus, right? So in that case, if there's a fact and there's a conflicting fact, there will be separate sort of document IDs associated with each of them. Now, during generation, again, there is some internal mechanism which we don't know by which the model decides which fact to output, right? And the thing we're checking is whether the associated citation is faithful to the thing that was generated. Now, I am not showing those results here, but they're in the paper. But actually, when you do all of these active indexing methods, you don't lose out on accuracy, right? So the actual accuracy of the answer is very similar. You don't improve on it, but you don't do worse.
And a question from me. When you are showing these performance, the synthetic data versus the test data, how much do you know about whether their distribution overlaps, or has the model just from your synthetic data generally learned?
So generally that overlap is very low. That's a question that the reviewers also had.
Yeah.
But you will notice that at least this backward indexing, the format is completely different, right? So this is not how any of our test sets look like. We are synthesizing multiple documents into responses. But even here, we did check, and very few or none of the questions had any overlap with the data sets that we were checking. Yeah.
You're reporting F measure, and I'm curious whether the errors are mostly precision or recall errors.
That's a good question. I think most of the errors are actually precision errors.
So it knows where it should cite, and it just gets the citation wrong?
Yeah.
And what does it cite instead?
So, one very common error case, I'm not sure if I have a slide for that, but one very common error case is that it reverts to a very generic domain, right? So a lot of times the information that it's generating is quite specific. It's maybe supported by a news article or something. But during training, our post-training data sets rely heavily on Wikipedia. So it's really prone, like in cases where, it's not sure what the actual...
So that must be in Wikipedia somewhere.
Yeah, it just cites Wikipedia. So that's the most common error.
A particular Wikipedia article?
About the concept that is mentioned.
Yeah. Okay.
Yeah. So, it's topically correct, but it just reverts to a generic Wikipedia.
It's not what was actually in the training data.
Yeah. So the main takeaway here is that, yes, model capacities are big enough that we can also add in citations in addition to all the factual stuff they store, and we don't observe any degradation on their accuracies when we do that. Scaling is one of the big sort of factors which makes this work, right? In our case, on an academic budget, we couldn't really scale up too much, but I think if somebody has more resources, they can do that. Lastly, we can actually combine this with retrieval as well. So I mentioned about non-parametric knowledge at the beginning. So even when the model is doing retrieval, when it has documents in the context, in practice, a lot of the things that are generated are not supported by anything in the context, right? So it's a mix of non-parametric and parametric knowledge. And we had some experiments in the paper which show that you can do a similar thing even when you are doing retrieval and get some boost in citation qualities.
Well, there's something fundamental that I'm sort of not happy with, which is that all the techniques you mentioned, they have this flavor of, here is some information, cite it as this. Here is some information, cite it as this. Here is some information. So it's the paper advocating for itself, or the cited document saying, cite me as this. That's what the pre-training or whatever looks like. And then at generation time, you want to go the other way. You want to say, here it is, and it's from here. To me, those are different tasks. So
that's really the bridge that active indexing provides, right? So
Yeah.
we're taking a pre-training data and we are rewriting it such that it resembles some of the.
No, what I'm wondering is whether this should then be followed by that supervised fine tuning that you did.
Oh, so I mean, all of the methods are represented.
Yeah.
Even when we do pre-training, we also follow it up with post-training. Without that, the model doesn't know how to do question
I
answer.
see. So there
That's
is
just
a
the language model.
and the fine tuning at whatever the post training part is the one that says, okay, since I'm producing this text, I should be referring to
Yeah, exactly.
this tailing.
So
Okay,
there's
got
two
it. Okay,
phases.
so
here.
there is
When
okay.
pre-training, you're just trying to memorize the document. Right?
Got it. Okay.
And during post-training, you're
Okay. No, for some reason I thought that you can do away with the post training once you do it this way.
I wonder actually about generating in the other order. So, if under a chain of thought, it says I should use this source, and then that might actually make it more accurate, as well as allowing it then to correctly credit that source in the
That's
text
really
that's absorbed
interesting.
by humans. Yeah, I mean, Ben Van Derme actually, who I think you met with earlier, has a paper called According to Prompting. I apologize, I don't remember who the co-authors were.
Our forward indexing pipeline looks kind of similar, right? So what we're doing is where the White House according to this document. We didn't actually test out the other direction, but I suspect that if you do this, you're going to kind of do better in that direction as well. What is interesting that forward indexing does help the other case as well, right? Where you're first generating the fact and then predicting the citation.
Right. Sorry, you mean if you train on cases where it's in the citation followed by fact,
Yeah.
and then you fine tune on fact followed by
Exactly.
citation, you transfer.
Exactly.
I'm wondering if I just feel like this isn't thoughtful, but I'm wondering if there's like a mechanistic interpretability component here. Can you actually? So you have a fact, and potentially you can train the model with some success to generate a source where the fact came from, but that doesn't necessarily mean that that source is actually where the model learned this information.
Yeah. So here I'm not making any claims about faithfulness, right? So I'm not saying that this is actually the document where this model learned it from. The question is, can we generate something which is actually verified? Does it actually entail the fact? I think the other question is much harder, right? Figuring out, and that's really what training data attribution has to do, right? And I've also thought about the mechanistic interpretability version, right? So can we actually localize part of the transformer where the fact is stored and is the citation stored in a similar region? I honestly, I mean, I'm not that convinced by all of the knowledge tracing methods. I think all of this is so diffuse across the model parameters that at best we can figure out that, okay, if you intervene here, your accuracy improves by a few points. And I suspect that if we apply one of those methods to this, we find that, again, the fact is distributed, the citation is distributed, and it's really hard to pin down some part of the network which is holding either of those. Okay, so in the interest of time, I want to move on. So now I'm going to talk about the second part, which is about model reasoning, right? And how can we externalize some of the reasoning process that undergoes how information is synthesized. So now I'm going to actually focus on this other paradigm that I talked about earlier, non-parametric knowledge, right? So in this case, one of the key mechanisms which enables language models to access non-parametric knowledge is attention over long context, right? And in fact, if you look at the development of LLMs over the last 5 years, context size is one of the dimensions along which they have really been scaled up, right? So back close to 2020, the context windows used to be 500 tokens. These days, it's common to see 2 million tokens of context. While just because this is great, right? So that means when I do web search or retrieval, I can put really long documents and I can put lots of them into my transformer. But just because a model has 2 million tokens of context doesn't mean that it's actually really good at using it, right? So there's been a bunch of work over the last year which actually shows this phenomena of context rot, where as you have longer and longer context and the model needs to extract some piece of information out of that, its accuracy degrades as the context grows long, right? And that's, again, not surprising. Now, one sort of framework which does help is having a bit more of an agentic interaction with the corpus. So here the idea is that instead of treating retrieval as a pre-processing step, where you once do retrieval get all the documents and throw it into the transformer, you have the model act as an agent and the retriever becomes a tool. So a typical pipeline would be given the prompt, the model issues a query, gets a bunch of documents, there's some reasoning over that, then issues another query, gets a bunch of documents, there's some reasoning, and so on. And at the end of it, it produces a final response. So this sort of a iterative retrieval and reasoning process, this improves accuracy, but I think more interestingly, this also sort of externalizes some of the reasoning, because now you can go in and you can look at all the queries that were issued to your external search engine, and they give you some idea about the process behind finding an answer. So the question that we were interested in here is what else can we externalize as tool use, right, when we are doing text processing? So here's some ideas. I've already talked about search, but here's some other tools which might actually be useful to agent which is dealing with a lot of text. So there's classification, being able to classify sentences or paragraphs into different categories. Pattern matching, so trying to find phenomena of interest in a large body of text. Parsing unstructured text into more structured formats, or counting and aggregating over the phenomena that you do detect.
Right. And you're saying basically these would be very fast tools that would run on the GPU, on the context that's on the GPU.
Not even necessarily the GPU, right? So some of these might even run on the CPU.
Okay, yeah, but you would basically cause generation, run the tool, and it would be very fast because it's not like web search or something.
Yeah, exactly.
It's more like a calculator.
Yeah, exactly. Yeah. And fortunately, we actually have language models which are really good at tool use now. So I'm talking about coding agents, which are essentially terminal-based assistants. So they can models like Codex or Claude Code, they can write Python programs, and they can execute them on the terminal. They can run bash commands. They can read intermediate files, store output files. And really, I think one of the strengths of coding agents, especially in the last few months, is not only that they're really good at tool use natively, they're really heavily trained to use tools, but they can define their own tools based on the problem at hand, right? So the setup that we were exploring here is actually quite simple, right? So let's say you have a long context task where you have lots of text. Traditionally, what you would do is you would put it in the transformers context window, and then condition on that and some reasoning, you would try to produce some sort of an answer. Now let's actually do something different. Let's take all this context and let's throw it in a file system and let a coding agent programmatically interact with that file system in order to solve the task, right? So before I go over the results, I want to show a couple of examples of what happens when we actually try to do this. So the first example comes from this data set called BrowseCom Plus, and this is really geared towards agentic search, right? So it's an iterative retrieval and reasoning process that I described earlier. So the question here is to find a professional gamer which satisfies 4 different constraints. They should be an American, born between 2000 and 2010. Their first major achievement should have been between 2015 and 2023. They should play for an American company founded between 2000 and 2010. And one of the company's founders should be married to a public health expert who earned her doctorate from a specific university. Right?
Totally normal thing to ask.
So, this is a pretty complex task, right? So you have these 4 constraints and 4 sets of entities which would satisfy those constraints, and you essentially want to take an.
This is how you create H1B ads so that you can hire the person you want.
Now, the actual text in this case is a corpus. So there's 100,000 documents where we know all of this information lives. So what we do is we just put it in the file system, and then we used OpenAI Codex with GPT-5. So this is what the sequence of actions looks like. It starts by doing a grep search for this phrase parenting in public, but this actually goes nowhere. It doesn't find any matches. So then actually it is a language model, right, at the end of the day, and it has a lot of parametric knowledge as well. So it focuses on that part about an American company founded between 2000 and 2010. It has some parametric knowledge about which companies, which gaming companies fit that criteria. So it does a grep search across those, and it identifies a co-founder of one of those companies. Next, it decides to do some pattern matching, looking for the wife of that co-founder, and it reads some files and it ends up finding this person who is plausibly the person being talked about in the query. It can then do some further confirmation about the university they attended. And now again, it's a language model, right? So by this point, it's fairly confident what the gaming company is. It again has parametric knowledge about who are the famous players who played for that gaming company. And based on another grep search, it actually finds the right fact, which actually tells it that this is the answer here. So I think the key point to note here is that there's a combination of things happening, right? So there is stuff that you expect out of language models, right? Knowing things like what is the American company founded between a certain year, who's the players who play for that. But with this tool use, it also gives a way to interact with the external worlds. Now, this here is a pretty similar pipeline to what any search agent is going to do, right? But one of the cool things about coding agents is that they can do other kinds of long context tasks as well. So here's another example from a different data set, which is called Oolong. And this is a very different kind of a problem. Here the question asks, in a data set of 1,700 sentences, and in this case, the context is just one file with 1,700 lines, identify which user has the most instances labeled as contradiction. In this case, one of the challenges here is that the file doesn't come with labels, right? So the labels need to be inferred from the actual text of what is there. So again, very similar pipeline, and this time we see very different behavior from the model. So it starts by looking at the first 250 lines of the text to understand a little bit about the structure. Then it writes a simple parsing Python script, which takes every line in that file and splits it up into a sentence pair and a user ID. Next, it actually starts to implement a simple rule-based contradiction classifier, right? And in its first iteration, this is really simple. It's just checking for negation across one of the two sentences in the pair. So it runs that contradiction classifier on some of the lines in that file, and it observes the result. And again, it is a language model, right? So it has this capability of looking at the outputs that its rule-based classifier has and figuring out whether it's doing a good job or not. So at this point, it decides to iterate and improve that contradiction detection script. So it goes in and adds some more rules like about quantity mismatches or about antonyms or numerical qualifiers, and gradually tries to improve that script more and more. At some point, it actually realizes, I think just like the NLP community did at some point, that it can do better by using machine learning. So it tries to install PyTorch and Hugging-Face transformers to build a better contradiction classifier. But this fails in the environment, so it just falls back to the rule-based approach it had, and then it writes a simple aggregation script for counting the number of contradictions and outputting the user which has the most contradictions. But again, I think the point here is that similar prompt, but a very different problem, and the approach here turned out to be very, very different from an agentic search approach. And in fact, pretty much whatever long context task we threw at the coding agent, we got really, really strong results. So here on the x-axis, we have 5 different data sets from this agentic search with 750 million tokens to long context reasoning tasks with hundreds of thousands of tokens to classic factoid question answering data set where you have 3 trillion tokens. But in each case, the setup is quite similar. In fact, the prompts are also very, very similar across all of these 5 settings. And really, the reason why it works so well is because we found that these recent coding agents are really, really adaptable. So if you look at so here in this table, what we have is search intensity, how many searches or grep-like operations is it performing per query, and code volume, how many scripts is it writing per query. And for search-like tasks, it tends to do more search, but for these other long context reasoning tasks, which require a lot of aggregation, it tends to write a lot more code. Now, we are not the only ones to notice, how powerful programming is as an abstraction for solving text tasks. I think recently there's been quite a, one paper that has been discussed a lot is this recursive language models paper from MIT. So actually the idea there is quite similar. At a high level, I think the main differences are that in the RLM approach, they use a REPL environment like a Python notebook, so a terminal environment, which coding agents do. And I think one other big difference is that in RLMs, there is this, the prompting really sort of encourages the use of a recursive subcall, right? So you can maybe identify a part of the problem and have another LLM sort of solve that problem within the Python notebook that you're generating and then use those results. So in our case, we didn't have any such recursive calls, even though, most generally a coding agent can also decide to write some script which would call an external LLM API. And at least for these tasks, we found that even without any recursion, you can do quite well. We've actually been pretty excited by these recent this whole framework of trying to solve NLP problems or machine learning problems and using programmatic interactions with the file system. So another example, and these are really fresh results, just sort of from last week. But here, this is an example of this this benchmark called RKGI, where the task is that you have an agent which is operating in a game-like environment, like Nintendo games, if you will, and it's not told the rules of the game. Right? So just by interacting with the environment, it needs to figure out what the rules are and come up with a strategy for solving that game. General frontier language models, they really struggle. I don't know how to bring that back. But general text-based language models or vision language models, they really struggle in this. They're not really able to bar even level 1. In our case, what we did was we used some of the intuition behind coding agents being good at analyzing long collections of text, and we tried to sort of instantiate an environment where we could use that for these games. So here the idea is quite simple. You can take all the logs of previous interactions with the game and just throw it into a text file with all those logs. And now you let a coding agent interact with those logs, again, performing things like rep search or writing Python scripts to extract some insights from it. And based on that, let it sort of figure out what the game is about, what the strategy should be, and then add it back to its own prompt so that it can continue interacting with the environment. And when you do that, we actually see really good results. So in our case, this Claude-based agent was able to solve all the public games in that RPGI benchmark, whereas I think with text or vision-based language models, you can't even pass level 1.
So I'm trying to look up this result. Are you sure it's AGI 3?
Yeah.
Does that exist? Has that been released yet? I'm not.
Yeah. So I think ArcAGI 3 is the latest. I don't know if there's a paper behind it, but they made 3 games public yet, and they're going to run a bigger competition with a bunch of hidden games.
All right, I'll ask later. I'm just trying to find. I'm searching for Claude Opus 4.6 and ArcAGI 3.
So our results are not public yet because
this is you. Yeah. Okay.
Because I just got this last Friday, but the benchmark is public, and the poor performance of most LLMs on this is also quite well known.
Very cool.
So again, the main takeaways is that interacting with text via code is surprisingly effective, right? And I think this is actually something which is recent. If we had done the same work maybe 6 months ago or 8 months ago, I don't think we would have seen any of these good results. But the latest iterations of these coding agents seems to be really, really good at interacting with lots of text. But again, one of the interesting things here is that these tool interactions, they do provide a window into model reasoning. How exactly is it going about solving a complex reasoning task, as was the case in the examples that I showed. And right now, I think, as I said, we're pretty excited about this sort of new framework. So we're also exploring multimodal context, right? Where you have, for example, scientific papers, where you have a collection of text, figures, tables. And now the question is, can you sort of interact with that data in a terminal environment to extract some information out? Okay, so I'm going to pause again for some questions, if there's any. Okay, so very quickly, I know we're maybe short of time. Do I have till 1 or till 1:15?
We can go past 1. 1:15 will probably be.
Okay, so I'll try to sort of run through this.
We have the room.
I'll run through this quickly. But in the last part, I want to talk about slightly older work on uncertainty, right? So far, I've really talked about where some information comes from, how is it reasoned over. But again, so one thing that we are often interested in is getting some sort of a confidence score about a prediction. Now, in machine learning, classically, you would have a setup like this, where you have some input, you predict an output, and along with that, you maybe give a score of how confident you are in that output. And generally, the interpretation here is that we want, this is like a probability that the model believes that the answer is correct. And generally, you want that probability to correspond to the true probability that the answer is actually correct. Now, in a lot of cases, especially for knowledge-intensive tasks, The kind of responses that we are looking for queries are not these short, simple statements, right, that you can evaluate objectively. Oftentimes you get these long pieces of text. And in this case, really the gold standard evaluation is to show them to a bunch of humans or evaluators and get some graded notion of quality from, right? So some annotators might say this response is 8 on 10, somebody else might say 6 on 10, and they're sort of aggregating judging many criteria in their heads on how to evaluate responses like these. You would also observe that there is often disagreement when we are evaluating long responses, right? So if you show the same response to 5 different people, you'll get 5 different judgments. So it's sort of a general way of thinking about the correctness of long responses is as a distribution, right? So you define some domain of interest, like scores between 0 to 100 or quality levels between 1 through 5. And during the annotation or evaluation process, you get some idea of some confidence as to how correct this response is. Now, these days, it's also common to use large language models themselves to do this evaluation. But again, the idea remains the same. You still have some amount of uncertainty in how correct something is. So the challenge, of course, now becomes that now let's say if I have a confidence score like 80%, it's not really clear what that means, right? It doesn't mean that the response, like I'm 80% confident that the response is 100% correct, or am I 100% confident that the response is 80% correct, right? So there is some ambiguity when you produce just a single confidence score. So really the argument that we try to make here is that for long answers, which have many different aspects to them, you should be thinking about confidence also as a distribution rather than a single score, right? And you should be producing confidence scores for every possible level of correctness that you have like the same domain that you would be evaluating at all. So now instead of making one statement, you can make multiple statements, like I'm 50% confident that the response is 100% correct, or I'm 40% confident that the response is 80% correct. And of course, you want all of these scores to sum up to 1. So now, if we accept this sort of a framework, then the question becomes, okay, what does calibration mean when you have a distribution of confidence scores? And there's many metrics that you can define. The one that I want to focus on is this idea behind selective FPOD, which essentially checks how useful is this confidence score if I want to abstain from answering in some cases, right? So the basic idea is that can we use whatever confidence scores we are predicting to define a decision rule, which would let me decide when an answer is high quality and when an answer is low quality. So in this case, we can simply sum up our confidence scores above a certain correctness level and check whether that sum exceeds a threshold. And if it does exceed that threshold, then I'm going to output that answer. And if it doesn't, I'm going to simply say, I don't know. So if you look at this sort of a framework and you compare several sort of standard techniques in the literature for extracting confidence scores, what we find is that generally in the literature you would have ideas like using self-consistency or self-evaluation or likelihoods of the generated sequence to construct sort of a single confidence score. For some of these, we can go and we can construct distribution variance where you're estimating the confidence score at every possible correctness level. And generally, when you do that, your accuracy of doing selective prediction does improve. So you can do a better job by considering the fine-grained levels of confidence. And it's worth noting that for different sorts of question answering problems, different methods tend to work better. So for example, these two data sets on the left here, these are very factoid sort of tasks, right? So you have a question and you have a list of facts or a list of items which are part of your answer. In this case, what actually works really well in terms of estimating confidence is to sample many responses from your model and check the consistency between all pairs of responses. Whereas here, we have certain different kinds of data sets. So these are more sort of abstractive in nature, where you have to summarize things into one query. Here, doing some continuous version of self-evaluation where the model is its own outputs, but on a continuous scale, that tends to work a little bit better. So again, the main takeaway is that for long responses, correctness is not binary, and our confidence estimates should reflect that. And when you do that, you can end up improving this idea of selective prediction, deciding when to answer and when to abstain. And this actually helps a lot in a cascaded setup where oftentimes for cost reasons, you want to deploy multiple models. A smaller one gets the query first predicts an answer, and if it's not confident, you want to go to a larger model. So improving calibration also leads to some budget savings or cost savings in a cascaded setup. So okay, I'm going to skip over this last slide. So I talked about a few of the papers from our group today, but I know we worked on a bunch of other related areas as well. And I would like to thank all my collaborators, especially the amazing group of students that I'm lucky to have. And yeah, thank you. Happy to answer any questions. I haven't been tracking questions on Zoom.
Yeah, that's all.
Do you have any, I feel like there's a nice connection between this work on confidence and the citation work. Do you have any future plans of combining something around like confidence and citation?
Yeah, I mean, so generally, I think the big limitation of the confidence work is that we are, we're really evaluating the whole response together. But I think what we really care about is to look at individual pieces and maybe have confidence scores. I think, actually, that's not what, I shouldn't say that's what you care about. I think both have their applications, right? So if you're only evaluating every individual fact or piece, then you don't know how these come together to form the overall response, right? But I think there is definitely a space of interesting research problems on trying to estimate confidence of all the assertions within a response and then seeing how they come together. And part of that could be about using citations or figuring out just the confidence of a citation itself. But yeah, I mean, the citation work is quite recent, so we haven't really worked on any extensions yet, but that's definitely worth exploring.
Okay. I had a comment on the citation, but the first 1/3 of the talk again. So I was thinking about the other work on citation, which is like, looking at scholarly papers, citation graphs, and there's a whole bunch of people working on it and so on, right? And a very powerful signal in that context is who else cites a particular document, right? I mean, this was Google's PageRank idea and all sorts of things. In the way you're approaching it, I don't see a way to bring that in. Because internally within all those documents, there might be a reference structure. Other queries might be referring to certain things. Do you see a way to sort of, because what that does is also takes care of things like what is an authoritative document to cite, because many other documents cite that document and so on. Like, it's a proxy, it's not like this thing. Yeah. So do you see?
Right now, I think the way we bring in any notion of an authoritative source is during post-training. So during post-training, you can decide which documents to cite your post-training data, right? And generally, you would expect to add reliable sources like Wikipedia things. And I'd like to also note that we sort of we explored it from the angle of taking all your pre-training data and adding citations to that. But I think that's actually how anybody would implement.
Yeah.
In practice, what you probably care about is identifying 15, 20 domains that you maybe really trust and are high quality, right? Wikipedia or
PubMed, maybe.
PubMed, or similar things that you can trust as being high quality. And actually, those are the kind of sources from which a lot of the parametric knowledge comes from. These sort of high quality, well-represented sources in your pre-training data, those are the cases where the model would not do retrieval and just directly produce an answer. So what I expect is that, if we were to do this at scale, we would really do it on a smaller curated corpus in a continued pre-training fashion, just like we did. And then, you have a little bit of that notion of authoritative sources. But I mean, I think the other part of your question is we are completely ignoring the graph structure behind, how information is stored in the world in practice. And I completely agree with that. I think, my PhD work was on using knowledge bases with text so that you can do reasoning or you can identify associations between sort of seemingly disparate documents. And I would love to bring that in to this work. Generally, I think, there's sort of a rich space of combinations of using structured knowledge in combination with language models. But yeah, I mean, it's something which seems to have fallen out of fashion, but I would love to revisit that. I mean, I think you can do multiple things, right? So during pre-training, your synthetic data generation component can use graphs, right? And we do that a little bit, right? So when we generated that backward indexing data, we identified similar documents or documents which were talking about similar concepts and then use that. But you can sort of create that chain more complex if you had structured,
Let's brainstorm offline. I think this is an interesting area.
So I want to have a link between the parametric and non-parametric knowledge. So how do you deal with the cases where, for example, there is a knowledge update where there's a conflict between the parametric versus non-parametric, and in some way that it's maybe the parametric knowledge is true, where like the non-parametric knowledge or the article you retrieve are like fake news, for example.
Great question, because that's exactly the slide I skipped. And this is actually one very good application of confidence scores. So what you can do is, exactly the situation that you mentioned, that the parametric knowledge says something, but the document says something else due to misinformation or whatever. So in this case, one thing that actually does help is confidence-based reasoning, right? So you let the model generate its own parametric answer, get some confidence score for that. Let the model reason about the, trustworthiness or, how reliable the non-parametric knowledge that it's getting is, and then compare the two to generate answers. So that sort of works, but what's more interesting is that we can sort of distill that confidence reasoning process back into the model itself, right? So first you do explicit confidence estimation for both sources, but then when you combine them, you can actually create this chain of thought style reasoning trace where the model internally does that. Okay, this is what the external evidence is saying, but I know that this other fact is true. Is it likely that it might have changed recently or not? And that sort of internal confidence reasoning also ends up working somewhat reasonably well.
There's a question on that.
Question online. How are the confidence generated prompt based or using logits?
So generally what we found is, there's two methods which tend to work quite well. So logit-based doesn't work for long generations because it's going to be dominated by uninteresting tokens. But two things that do tend to work, if you have access to model internals, then using the hidden states, for example, at the last token and using a small sort of calibration set to train something like a linear probe on that, that is a good confidence, that is somewhat better calibrated. Or actually consistency-based confidence measures tend to work quite well, where you sample multiple responses from the model and you check how many of them agree with each other. So that would be applicable in the case where you don't have access to model internals. Yeah.
Is there a scenario where this could actually, let's say the parametric knowledge is actually correct, or I don't have an intuition for which is which, but you know what I'm saying. Like, let's say the situation is reversed. Is it possible, or is the model sort of forever rooted irrevocably in its pre-training?
No. So actually, in practice, if you don't do anything special, models are very susceptible to external evidence.
Okay.
So if you add some passage to the model's context, it ends up agreeing with that context even when it's wrong.
Okay.
So the problem is to actually let it train it to override external evidence and trust its parametric knowledge even when they're in conflict. When its confidence is really high.
Okay. So this is an example where you've overridden the context.
Yes.
Okay. Appropriately.
So like all of this training is learning to cite, etc. I'm just wondering, like, what is the information foraging behavior of these like models, because when we cite information or the way we cite information, it's a lot of synthesis and a lot of processing. And, like if you're talking about, like non-parametric and parametric knowledge, that could be like our own worldviews versus like extrinsic information that we get. And there's some like, ways, the information foraging theory or like different ways that we know that how we forage information. I'm just wondering like, what is your intuition on how is the model foraging information and dealing with, let's say, you're talking about conflicts here, but even in external sources, there can be conflicts and you can have like constant knowledge updates, and especially places where, it's not a factual question, but it's more sort of a synthesis that requires your own interpretation of that, material or like conflicting materials. Then how does it deal with the citations? Because I look at citations as sort of like an externalization of the information foraging that the model is doing.
Yeah, I mean, so ideally that's what you would want out of citations, right? That they give you a window into the actual information gathering process or where something comes from. But you know, at least the way we studied it, that's not necessary. Right? It's not. So I'm not going to make the claim that if a model is generating a correct citation, that is actually the document from which it picked up that fact. Right? That fact, I mean, generally facts appear in many documents. So all we are checking is whether the model at test time is producing one citation into a document which contains that fact. So it's hard to say, you know, how, what is the process by which knowledge is stored in the model's weights. It is also, I mean, and that doesn't just apply to parametric knowledge, right? So even in the non-parametric case, as you said, if you have many documents coming in and there's some conflicts, it's really hard to tell what exactly is the process by which the model chooses one over the other. Now, my intuition here is that post-training is where a lot of this behavior it goes in, right? So there are certain kinds of documents that are favored in the post-training data, right? And certain sorts of sources which are preferred in the post-training data. And those are the signals that the model is internalizing. Now, again, my hope is that the second part of the talk where I talked about coding agents and how you know, they externalize a lot of the reasoning process. We're not quite there yet, right? Because even a coding agent, at the end of the day, what it is really doing after it gets those outputs of the tool calls is still an attention window. But again, if we can offload more and more things towards programmatic execution without sacrificing accuracy, then I think things become more inspectable. So, you know, that's part of the reason why I'm excited about the whole coding agent kind of work.
Okay, well, let's thank Bhuwan again. And I think there's 4 students taking you to lunch now.